Hi, grade 10. So today we're doing lesson 5.2 and 5.4. We're just combining them because they go together. So there's a handout on Teams that you should print out and fill in as you watch this video. So at the top of the 5.2 handout, it says key ideas. Congruent figures have the same size and shape. Similar figures have the same shape but different sizes. So congruent figures have the same shape and size. So if I drew two exactly the same triangles, they're congruent. And the symbol for congruent is an equal sign with a wave on top of it. Similar shapes have the same shape but a different size. So these two are similar. And the symbol for similar is just the wave. So below that it says similar triangles have the following properties. Corresponding angles are equal. So this is for similar. So if I had two triangles, TUV and ABC, then angle A in this one is equal to angle T in that one. So those theoretically are both 90 degrees. Angle B is equal to angle U. And angle C equals angle V. And then the ratios of the corresponding sides are equal. So the side AB is is a ratio to the side TU, and that equals the same ratio as the side BC over UV, and that equals the same ratio as the side CA over VT. So you could also write that in ratio notation. AB to TU equals BC to UV equals CA to VT. So some examples. Which two of the three given triangles are similar? Find the scale factor for each pair. So I'll start by drawing the triangles. So there's a pair of triangles, so two of these are similar, meaning they're going to have the same ratios of side lengths and angles. So the first one is ABC, DEF, and GHI. 5, 8, 7, 38 degrees, 59, 7, 4, 6, 3.5, 2, and 3. Okay, that's everything we know. So we'll start by comparing these two to start. So we're going to set up a ratio of their side lengths. So the length of AC is in the same place as DF. So we're going to do AC over DF equals AC is 8 and DF is 7. So that equals 8 over 7. 8 divided by 7 is about 1.14. So the ratio, or the scale factor, for this one is 1.14. Now we need to compare another side length to check if they're the same. So we can compare AB to DE. So AB over DE equals 5 over 4. And 5 divided by 4 is 1.25. So these do not have the same ratio. So these two are not similar triangles. Not same ratio. So not similar. Now we'll do these two. So we'll start by comparing DE to GH. And that would be 4 over 2. And 4 divided by 2 is 2. Then we'll compare DF to GI. DF is 7. GI is 3.5. 7 divided by 3.5 is 2. So far so good. Now we need to compare the third side just to confirm. So we're going to compare EF to HI equals 6 over 3, and 6 divided by 3 is 2. So all sides are the same ratio. Therefore, these are similar triangles. And what's the scale factor? The scale factor is 2. Okay, so that means that this one is 2 times as big as this one. That's the scale factor. Okay, on to the next page, number 2. Triangle ABC has sides AB 9 centimeters, BC 12 centimeters, and AC 15 centimeters. Triangle YXZ has sides YX equals 6 centimeters, XZ equals 8 centimeters, and angle X equals 90 degrees. Show that they are similar. All right, so I'm going to start by drawing these. So triangle ABC, triangle YXZ. So make sure you're writing these in the same order that they're given to you, because the order does matter. And then AB is 9 centimeters, BC is 12, and AC is 15. YX is 6 centimeters, XZ is 8 centimeters, and angle Z is 90 degrees. So this one I should have drawn as a 90. Okay, so we're missing a side length for YZY, but since this is a right triangle, I'm able to find that side length using the Pythagorean theorem. So, Pythagorean theorem, A squared plus B squared equals C squared. So remember that C is always the hypotenuse, which is opposite the 90 degree. Sorry, I wrote this incorrectly. Angle X is 90 degrees, not angle Z. There we go. So the hypotenuse is always the one that's opposite the 90 degree angle, so that's the one we need to find, and that's letter C. So I'll plug in the other two. So 6 squared plus 8 squared equals C squared. 6 squared is 36. 8 squared is 64. Equals C squared. 36 plus 64 is 100. Equals C squared. To find C, we need to take the square root of both sides. So C equals 10. So we know that this missing side length is 10. Now, we can set up the ratios to check if these are all similar. So we can also write it like this. So AB over, so AB needs to match with XY equals BC over XZ equals CA over ZY. And now below it, we can plug in these numbers. So AB is 9, XY is 6, so 9 over 6 equals BC is 12 over XZ is 8 equals AC is 15 over YZ we just found is 10. Now we're going to check if these all equal each other. So 9 divided by 6 is 1.5, 12 divided by 8 is 1.5, and 15 divided by 10 is 1.5. So these do all equal each other. All three ratios are equal. So therefore, these are similar triangles. All right, number 3. Determine the unknown measure x. So these two triangles share angle C. A, B, E, and D. This is 4 centimeters, 3 centimeters, 6 centimeters, 5 centimeters, and AB is X. So I need to find X. This is part A of number 3. And these two lines are parallel, AB and ED. So I know that triangle ABC is similar to, that's what that wave means, triangle DEC in that order. Because they share angle C, it's like this triangle here is turned that way. So it rotates around so that angle D matches up with angle A, angle E matches up with angle B, and angle C stays the same. Okay? So that means AB over DE match, and BC matches with CE. So if we set up this ratio, we'll have an X in there, and then we can solve for X to find what we're missing. So AB is X, over DE is 3, BC is 6, over CE is 4. Now to find a missing term in a ratio or a set of fractions, we cross multiply and divide. So we start by multiplying the two terms across from each other that we know, the two terms that we know, so 6 times 3. And then we divide by the remaining term, which is 4. And that means this whole thing will equal X. So X equals 6 times 3 is 18 divided by 4. 18 divided by 4 is 4.5. So that means the length of AB is 4.5. Now letter B of this question. I have this set of triangles, one inside the other. These two lines are parallel. I have L, M, N, and I have PQ. ML is 15, MP is 5, and Q is 4, and LN we don't know, it's X. So that's what we need to find is X. Triangle LMN is similar to triangle LPQ. So this smaller one in here, it's the same shape but different size than this bigger one. Right? So we're going to compare those two, one inside the other. So side length LM matches up with LP from the bigger triangle, and side length LN matches up with LQ from the bigger triangle. So LM is 15 over LP. The total of LP from the top all the way to the bottom is 15 plus 5, so that's 20, equals LN, which is X, we don't know. LQ is X plus 4. Now we're going to do the same thing we did last time. We're going to cross multiply and divide. But now we're missing an X and an X plus 4. So we're going to solve for this X. We're going to say X equals, multiply the two terms across from each other that we have. So 15 times X plus 4, and divide by the remaining term, which is 20. Now we're going to simplify. So 15 times X is 15X, plus 15 times 4 is 60, divided by 20. In order to get rid of the 20, we'll multiply both sides by 20. These ones will cancel out. Now we have 20x equals 15x plus 60. We'll subtract 15x from both sides to get all the x's on one side. Now we have 5x equals 60. Divide both sides by 5. X equals 12. So the missing side length is 12. All right, moving on to lesson 5.4. 5.4 is modeling with similar triangles. So the scale factor or the scale ratio, those are the same thing. What is that? That is a measure of the amount of enlargement or reduction that relates one similar triangle to another. So if triangle ABC is similar to triangle XYZ, let n be the scale factor then the following is true. The length of any side or altitude of triangle ABC, so the length of any side of ABC, equals n, the scale factor, times the length of the corresponding side or altitude of triangle XYZ. Also, the perimeter of triangle ABC equals n, the scale factor, times the perimeter of triangle XYZ. And the area of triangle ABC equals n squared, because it's area, times the area of XYZ. Okay, so there's some important things to note that you might need to use in your homework. All right, let's do a couple examples. So if triangle ABC has the following properties: AB equals 4 centimeters, BC equals 3 centimeters, and angle B equals 90 degrees, and triangle XYZ has side length XY equals 8 centimeters, YZ equals 6 centimeters, and one angle is 90 degrees. We don't know which one. Then we need to do two things. A, show that there are two ways to draw triangle XYZ. And B, explain why one of these triangles is similar to ABC. Okay, so we're going to start by drawing the two options for X, Y, Z. So there has to be one 90-degree angle in here. So we could have X, Y, Z, where X, Y is 8 and Y, Z is 6, and that's a 90-degree angle. Or we could have X, Y, Z, where X is 8, XY is 8, ZY is 6, and we don't know the other side length. We then would draw triangle ABC. Angle B is 90 degrees. AB is 4, and BC is 3. Now we can find the missing side lengths using the Pythagorean theorem because these are both right triangles. So we need 1, 2, 3 missing side lengths. So for the first one, we need to find the hypotenuse, which is c. So we have a squared plus b squared equals c squared. So we have 8 squared plus 6 squared equals c squared. 64 plus 36 equals c squared. 100 equals c squared. So 10 equals c. So this one is 10. The next one, we know the hypotenuse, but we're missing one of the other side things. So we have 6 squared plus b squared equals 8 squared. 6 squared is 36 plus b squared equals 64. We will subtract 36 from both sides. 64 minus 36 is 28. And then we will take the square root of both sides, and b will equal 5.29. So that means this one here is 5.29. And then to find the last one, we need the hypotenuse again. So 4 squared plus 3 squared equals c squared. 16 plus 9 equals c squared. 25 equals c squared, square root of both sides. 5 equals c. So we have all the missing side lengths now. Now we can show that one is similar to the other, so we need to set up our ratios. So this is part of letter B. So xy over AB, this is for the first option for xyz. Xy over AB equals 8 over 4, which equals 2. YZ over BC equals 6 over 3, which also equals 2. XZ over AC equals 10 over 5, which also equals 2. So therefore, triangle ABC is similar to triangle XYZ. But now we need to show that the other one is not. So we have XZ over AB, which is 5.29 over 4, which equals 1.3. Then we have XY over AC equals 8 over 5, which is 1.6. And then we have ZY over BC, which is 6 divided by 3, which is 2. So these are not the same. In fact, none of them are the same. So these two triangles are not similar. So that's why it's important to draw all the options for a triangle, because if some of you chose to draw it one way and some of you chose to draw it the other way, we would see that not all the answers were the same. Okay, now we're going to do some examples from the textbook, so turn to page 474, number 2. And this question says, David held a 30-centimeter ruler far enough in front of his eye so that a cabinet on a far wall appeared to be 30 centimeters tall. The ruler was 45 centimeters in front of David's eye, and he was standing 3 meters from the cabinet. Use a scale drawing to determine the height of the cabinet. So, here's David. He's holding out a ruler 45 centimeters away from him, and the ruler is 30 centimeters tall. So this will form a triangle. For all of these questions, you're going to want to try to make 2 similar triangles. Then we're going to draw a similar triangle which demonstrates the distance to the cabinet. So the cabinet he's 3 meters away from the cabinet. We need to find how tall the cabinet is. So obviously the cabinet forms a right angle with the floor. Now, we need to notice that this is a turned version of that triangle. So the 3 meter side is going to match up with the 45 centimeter side, and 30 centimeters is going to match up with this missing x. So we're going to start with a ratio. The first thing we need to do is to put everything into the same units though. So we have 45 centimeters and we have 3 meters. 3 meters is equal to 300 centimeters. So let's use that. So we have 45 over 300 equals 30 over x. So we're going to cross multiply and divide. X equals the 2 terms we know, 300 times 30 divided by the remaining term, which is 45. 300 times 30 divided by 45 equals 200 centimeters, which is equal to 2 meters. Therefore, the cabinet is 2 meters tall. Perfect. Okay. Next, we're going to do number 6 on the next page, 475. We're not going to do all parts of it, though. We're just going to use the diagram there. So, it says, Sharon is sitting beside the lighthouse on a sunny day. So I'm just going to draw the picture. So here she is, standing there. She is 1.6 meters tall, and she's standing 4.8 meters away. Now the realistic drawing of the lighthouse here is 75 meters away, and we want to know how tall it is, so that would be labeled as X. So we're just going to set up a scale, a ratio, to see how tall is the lighthouse and what is the scale factor. Those are the two questions we're going to answer. So we have 1.6, which is her height, over X, the height of the lighthouse, we don't know, equals 4.8 over 75. We're going to solve for X by cross multiplying and dividing. So 1.6 times 75 divided by 4.8. Plug that into your calculator. 1.6 times 75 is 120 over 4.8. X equals 25. So therefore, the lighthouse is 25 meters tall. Now the scale factor, we would do 4.8 divided by 75, one of our ratios. That equals 0.064, and then we'll just check with the other one. 1.6 over X, X was 120, or X was 25. So 1.6 over 25, and that also equals 0.064. So the scale factor is 0.064. Okay, and then the last one, number 9, which is on the next page, 476. We just need to find how wide is this river. So we have a little diagram here. You need to notice where the right triangle or the right angles are so that you can use them to help you solve the problem. So we need to find the width of the river, which is X over here. So notice that this triangle would be turned to be over top of that triangle. So our ratio is going to be 30.2 over 14.6, because those two, once this triangle is turned, those two would match up, equals X over 5.8. So I put the X on top because I put the 30.2 on top on this side. Now I'm going to solve for X by cross multiplying and dividing. So 30.2 times 5.8 divided by 14.6. If you plug that all into your calculator, you will get 11.997, which rounds up to 12. So therefore, the river is 12 meters wide. Okay? Let me know if you have any questions, and I'll talk to you soon.